folks. This is Aaron Brooks. I'm here to talk to you about the rotational crop water and nitrogen use aspects of the LIT project. The main objectives of this aspect of the project is really examining specifically the seasonal annual water and nitrogen budgets for these business as usual and diversified rotations. And in the drier zones, it's really, is there sufficient soil water available to establish these more intensified fall seeded crop rotations, especially ones that are replacing crop fallow. And then how do these intensified cropping rotations affect nitrogen fertilizer requirements? And finally, what climate conditions are these crop rotations viable? I'm working on this aspect with Kendall Call, and part of what I'm presenting today is some of the crop yield and forage quality data that's working with Dr. Kurt Schroeder and Sagat Boscata, and Jody's involved in everything too. Just to review the project design, we're looking at really the main thing I'm presenting today is looking at the strip trials in St. John and the strip trials in Genesee. At the intermediate zone, we're replacing fallow with winter pea or a spring cover crop, so replacing fallow. In the high precip zone, we have the incremental crop rotation is a winter pea crop rotation that is replacing a spring chickpea. And the aspirational crop rotation in Genesee is when we're going to replace the spring wheat with a winter cover crop. So the winter cover crop, chickpea, winter wheat rotation. So essentially at this point eliminating one cereal crop that has nitrogen demand. So in that sense, our aspirational is actually reduced, already has reduced nitrogen fertilizer requirements. These plots are set up essentially by 9.8 meters or 10 meter wide by 23 meter deep strips. We have 3 crop rotations and 3 crops in each rotation. And so 3 by 3, there's 9 crops total if you look at all 3 crop rotations. And so we've set up these field trials so they're 9 strips where each strip then represents one of the crops in that rotation. This is the setup helps us because then we can actually look at crop yield production for every crop every year of the project. And actually what I'll be doing is looking at the total crop production or biomass production from a specific rotation by just summing up the production each of these strips. And we have you can do this in one of 5 reps, and so we'll take in the average of all 5 reps in this project. So that's the main design that we're looking at. Throughout the project, and particularly in this presentation, I'll be looking at crop yield, above ground biomass, both those taken at harvest. We also did a pre-plant and post-harvest soil water content measurements. We did pre-plant and post-harvest soil sampling where we looked at nitrate ammonium to actually get a nitrogen balance, and we looked at nitrogen uptake in the crop itself. And that's also measuring forage quality with time. Especially for the cover crops, how is the forage quality changing? And we also do have some automated measurements. We're not going to show them here, but we put some soil moisture sensors out there to look at changes throughout the growing season. So let's get to the results. We did have some livestock grazing in the cover crops in the field experiments. I'll just touch briefly on some of the results there. So just to give you a little bit of context, in 2018 we had a fairly dry season, a dry fall, and to some extent this may affect some of our results. You can see from July 2018 up until November. December we finally got some higher precipitation, but this dry fall kind of potentially could affect our germination and initial growth in the fall for our winter wheat. It was a fairly cold winter in 2019, and we can see in 2019 we had fairly erratic precip, one month being really high precip and one month being low precip. So if we look at crop yields, this is the intermittent precip zone. This is out at St. John, and these bars represent the winter wheat and the spring wheat crops, and the business as usual and aspirational. So the ASP being aspirational, this is the one where we incorporate cover crops instead of fallow. Business as usual has the fallow within the rotation, and the incremental has the winter pea, and you can see the yield of the winter pea there as well. So this is crop yield in kilograms per hectare. You can see the winter wheat, the greatest yield was the winter wheat we had in the business as usual rotation. So this is winter wheat following fallow. And this was 20% greater than winter wheat response following cover crop here in the aspirational, and winter wheat following winter pea here. The spring wheat yields were about the same in all three. So there's a 20% hit, potentially due to water shortages. At Genesee, the winter wheat was all about the same within all three of these crop rotations. The chickpeas in the aspirational and the chickpeas in the business as usual were less than the yield of the winter pea yield. So winter peas were about 26% greater yield than the chickpeas. If we put these two side by side, one of the interesting things is the magnitude of the winter wheat yield we have at St. John, which is actually greater than the winter wheat yields we're getting at Genesee for that same year. So the winter wheat following fallow is greater than the yields that we had at Genesee. Pretty interesting to see that dynamic, and whether that was due to more water available or nitrogen, I'm not sure. The rest of the yields are somewhat higher at Genesee than at St. John, as you might expect. Rotational biomass, so how much biomass actually was produced in the rotation. So we're summing up all the biomass of the three crops in a specific rotation. So business as usual, the red or orange being for Genesee, and the blue being for St. John. You can see in general the Genesee biomass production biomass is typically greater, at least for the business as usual incremental. The aspirational Genesee was actually less, and it could be how we terminated the cover crop. Maybe sooner at Genesee than at St. John. The incremental crop rotation, the increase using winter pea was actually greater biomass production both at Genesee and St. John than the other two rotations. So the winter wheat production actually, like yield, was actually pretty good. So 34%, 16% greater than business as usual at St. John and Genesee. Soil water loss, if we look at individual crops and how much water was lost during the growing season, we could see even the fallow plots. And fallow, we try to store as much water, but even then we still have evaporation, and we have 16 centimeters of water were lost from the summer fallow plots. The cover crop also lost another 10 centimeters, about 25, and potentially you can reduce this water loss from cover crops by terminating the crop or grazing the crop or swathing the crop earlier in the season. So this is something we can moderate. Residual nitrogen in the soil. This is how much nitrogen we took right after harvest. We took soil samples. Interesting to see fallow had how much 120 kilograms per hectare, or essentially 120 pounds per acre of fertilizer available. And this is as the organic matter mineralizes. So you can see some of the benefits of summer fallow here, just the nitrogen available. Cover cropping in the aspirational at St. John actually almost got 100 kilograms per hectare. Winter pea has a lot of residual nitrogen, so there seems to be certainly a nitrogen benefit from these winter peas and the cover crops. The fact that these orange bars in general are higher, so we have more residual nitrogen at St. John versus Genesee. We're not exactly sure why, and it could be we might have over-fertilized in some of these, or the production was higher in Genesee than we got at St. John, so we had more crop usage of nitrogen. That this is a significant amount. So over the summer fallow, these soils, even at St. John, fill up in the fallow, and they result in lost water, that we could use that water for more vegetative growth. Forage quality. So if we look at the green line represents crude protein, and so this is essentially the amount of nitrogen in the cover crop. The yellow bars being the dry matter weight, and so we can see at different times from May 29th till July 2nd, 4 different harvests, and we saw how the forage quality goes down, but the forage biomass goes up. Most of the time when we try to terminate a cover crop, we try to maximize the biomass and the crude protein. But in this case, we may also think about this in terms of water usage by these cover crops. And so like in St. John, we may need to start terminating these cover crops sooner if we to prevent having a yield hit in the winter wheat following the cover crop. So some of the things we're starting to. So here's a summary. We replaced summer fallow in the intermediate precip zone. This with winter pea and cover crop. This replacement led to 20% losses in the winter wheat yields. Here again, maybe there's too much water demand. Maybe it was just a colder fall that led to this. Summer fallow still has 20% soil water loss that could be used for biomass production. So summer fallow is not totally efficient either. Water use and biomass production is really greatest in the winter peas. So the winter peas actually produce fairly well. So at St. John, it's terminating these cover crops sooner, potentially before flowering, even though they may not be the maximum forage amount and quality. We may want to do that to conserve water and reduce the effect on subsequent winter wheat yields. In the high precip zone, there's no impact of winter pea or cover cropping on winter wheat yields. The winter pea rotations outperform the chickpea rotations in terms of biomass and yield. The cover crop rotation used the least amount of water, and there seems to be, since we have plenty of water at Genesee, there's opportunities for multiple grazing periods. Maybe do it in May and then in August if you can get some more regrowth in these cover crops. So we can use quite a bit of that water with biomass. Replacing that spring wheat with winter pea does eliminate a year of nitrogen fertilizer, increasing profitability, but we did see actually more nitrogen, residual nitrogen in these peas and cover crops, so there is even a benefit in itself. So there's the total nitrogen use is probably going down. And at Genesee, we actually had documented weight gain, and we gained about 2.5 pounds per day with cattle grazing these cover crops in the tower fields, which is a pretty good weight gain. So this is good quality feed. So what are we doing next? We're going to continue monitoring strips and field sites for another year. It'll be really interesting, especially in the field experiments where we're looking at winter wheat yields following cover crops in a large field. So we can actually see, do we have a yield hit this year in the field studies? And we're going to start getting into looking at the modeling and profitability of these different alternative cropping systems. So more to come on that. Thanks for listening.